All right, in this video, we're going to be talking about the Unit 7 Quiz 4 review. So let's go and just dive right into it. So first thing we're looking at is a task graph, or I'm sorry, a task diagraph. And so we are needing to take all that information and fill out the chart. So let me zoom out so we can kind of see a little more of it. Awesome. All right, so first off, a couple things where some people are getting confused, and that is these first two columns. This column here, this is all observational. All right, so there's nothing you need to figure out. All right, so it's literally just taking the information from all up here and then throwing it right down there. Okay. First off, the time for start, I already gave it to you. All right, so the time for A, that is 2 because there's 2 on the arrow. All right, that belongs to 2, or that belongs to A. All right, so B has a 3. Let's see, C has a 5. D has an 8. E has a 6. Let's see, F has a 12. G has a 20. And lastly, H has a 1, I believe. And yep, that's it. All right, now the prerequisite task, all it is what's being pointed to it. So looking at A, what's pointing to A? Well, that's the start. So that's going to be none. Same thing for B, which is none. Same thing for C, which is none. All right. Now, let's look at D here. All right, D, I have 2 arrows. One arrow is from A, the other arrow is from B. So I'm going to write the prerequisite A, B. All right, so F looks like AC. All right, I said F. Okay, I did say F, didn't I? So I put that in the wrong spot. All right, let's move that down there. All right, sorry. E, okay, E is an A. All right, so hopefully you're not telling me in class I messed up. I just fixed it. All right, so G, let's see, G is a DE. And then lastly, what is pointing at H? H is an EF. All right, EF. All right. Now, lastly, we have to figure out the ESTs. That's the ESTs where we put little numbers on everything. All right, so all the little numbers that we put on top of the diagraph here, the vertices, that's the EST. So A, B, C, they're all pointing at start, so all that will be zeros. All right. Next, let's look at vertex D. All right, D, you have 2 arrows going to it. I'm going to take the longer time. All right, so E, you only have 1 arrow going to it, and that's A. F, you have 2 arrows going to it, so the longest total time would be 5. All right, so G, let's see, you have 2 arrows going to G. Let's see, D can get to 8 in 11 minutes. E can get to 8 in a total of 8 minutes. So obviously, we're going to take the total, or the largest total. Let's see. Here, E can get to 8 and I'm sorry, E can get to 8 in 8 minutes. F can get in 17. So we're going to take the larger number. So let's see, H finished. That would be a total of 18, 11, 20. That would be a total of 31. We are going to take 31. Now remember, 31 is the minimum project time. All right, so that's MPT. Now to figure out this last column here, I'm just going to take all the information that I found and just start throwing it in there. So let's see, C is 0, D was 3, E was 2, F was 5, E was 2, F was 5. Let's see, G ended up being 11. H was 17, I believe, and lastly, the minimum project time was 31. All right, now the critical path. All right, let's start highlighting. Let's see. A, B, and C all became 0 because of it came from start. Let's see. F became 5 because it came from C. D became 3 because it came through B. E became 2 because it came through 5. All right, so we got 3 paths going on right now. But I think some things are about to cut down. All right, H became 17 because of F here. G became 11 through D. All right, and then lastly, minimum project time. All right, so I'm going to highlight in green. Let's see, B, D, G, and finish. So I'm just going to type that out right up here. I'm not going to go down to the very bottom. Start, B, D, G, finish. And that's my critical path. All right, next one. All right, create a diagraph. A diagraph is an arrows. All right, it's a whole bunch of arrows. So let's go ahead and do a diagraph. Remember, the arrows is always going to the larger, or I'm going to the second one. So let's see, that's A to B, B to C, E to F, D to F, C to A. All right, C to D. Oh, sorry, C. Let's try that again. So that would be C to D. I got smaller arrows. I messed up. All right, so E to D. All right, C to E. Let's see, C to E. All right, F to B, F to B, B to E, B to E, G to H. There's a E to C. This is actually a pretty long one. All right, A to F. Let's see, A to F, and then lastly B to F. All right, there we are. All right, so what is the end degree of vertex G? Let's see, how many degrees are actually going into G? Nothing. There's an arrow leaving G, but nothing going into G. So that would be a 0. Find the out degree of vertex A. Out degree, notice you have one arrow coming in, but 2 arrows going out. The answer is 2. All right, so consider if the graph is an Euler path, Euler. All right, so we're doing all. All right, so let's see. First off, let's go ahead and do Euler path. Remember, Euler path, it has to have exactly 2 odd vertices, so let's go through. Vertex 1 has a degree of 2, that's a 2, that's a 4, that's a 2, 1, 2, 3, that's a 3, that's a 3, and then that's a 2. All right, so obviously we have an Euler path. All right, so we have an Euler path. Now, if you remember, an Euler circuit has to be all even, which obviously we're not going to have all even. All right, now, let's go back to the Euler path. All right, so if I was going to find a route, I'm just going to start with 3 right here. Boom, boom, boom. There we go. Awesome. That's it, Euler path. All right. Next is a Hamiltonian circuit. Let's see, next one is a Hamiltonian circuit. That means I'm connecting the dots and getting back to my starting point. So this is a guess and check situation. Let's see if I can get back to my starting point. Oh, nope, can't go back to that 3. All right, can't do that. That's a no-no. All right, let's try it one more time. Can I get back? Nope, can't get back. Can't do it. But I did create a path. I don't know if you noticed that. I started here, swung around, boom, boom. All right, so there we are. So the only 2 things I can make out of this is a Hamiltonian path. So Hamiltonian path and an Euler path. All right, moving on. All right, so next one, again, Euler path. In fact, I'm going to write it like this. So Euler path, Euler circuit, Hamiltonian path, Hamiltonian circuit. All right, I don't think I need to spell out circuit. Hopefully you know what it is. All right, so let's just go ahead and figure out with Euler. So let's deal with the degrees. Remember Euler, we got to deal with degrees, so that's a 2. 1, 2, 3, that's a 3. So automatically I already know it's not going to be a Euler circuit. That's a 1, 2, 3. That's a 2. Let's see, 1, 2, 3, 4. That's a 2. All right, so what we have here is a situation that it will be an Euler path because it's exactly 2 odd vertices. So let's just see if we can figure it out. Up there, all the way there. Awesome, there we go. All right, Hamiltonian path, or we'll do Hamiltonian circuit. That's easier. All right, there's my Hamiltonian circuit. Very simple. Now let's see if I can do a path. I bet I can. All right. Now, if you remember, I'm going to go through this again, and that is, if you do something like this, I'm going to say that's wrong. The reason why is because you can easily just continue this. All right, so don't get lazy on my paths here. Remember, where you stop and where you finish, you can't get back. Oh, there we go. That's perfect. That was my starting point. That was my ending point. I cannot get back to my starting point. Awesome. All right, let's see. Next one. So I can do a little magic here. Right click, clone, awesome. I'll do that one more time. Right click, clone. Right click, clone. All right. Hopefully that's going to save a little bit of time. All right, so Euler path, Euler circuit. So again, go ahead and let's go ahead and do the degrees first. Notice how I'm always doing the degrees. All right, so the degrees, let's see, E has a degree of 4, D has a degree of 4, C has a degree of 4, B has a degree of 4. Look at that, they're all even. So I already know that it's not going to be an Euler path. All right, so Euler circuit, here we go. There we go, there's my Euler circuit. All right, Hamiltonian, we're going to go ahead and do Hamiltonian circuit first, because that's always kind of the easier one. Oh, look at that. That's my Hamiltonian circuit. Awesome. Let's see if I can do a Hamiltonian path. All right, throw it back. All right. All right, starting with E, let's see if I can just connect them. Oh, I can get all the way back to E. That's a no-no. Can't do that. That's a circuit. Let's see if I start at D, something like this. Nope. I can always get back. Okay. Maybe I should have paused the video. I know I can do this, I think. Let's see if I can. Oh, watch this. Oh, there it is. Perfect. I cannot get back to my starting point. There's my Hamiltonian path. All right. Next one is Euler again. Again, hopefully you're fast forwarding the video. You don't need to see me do this. Oh, there's my first odd. I know it's not going to be circuit. 2, 4, A is 3, 2, 2, 2. All right. Exactly 2 odd vertices. So the answer is going to be, I have an Euler path. So if I was to do this real quick, okay, I get a little crazy there. Hold on. There we go. There's my Euler path. All right, Hamiltonian circuit. Let's see if we can do that. All right, just trying. Nope, can't get back to my starting point. So I already did a path. And I'll go ahead and tell you, just for time's sake, I cannot do a Hamiltonian circuit. I cannot get back to my starting point. That's a no-no. All right, next one, Euler. Let's go ahead and do this. All right, so that's a 2. That's a 2. H is a 3, so I already know it's not going to be a circuit. F is a 3. C is a 3. Oh my goodness, look at that. There's actually more than 2, so I know it's not going to be Euler path. All right, so it's got to be Hamiltonian. Let's see. All right, let's see if I can do this. Well, I can't get back to my starting point, but I did make a path, so awesome. I think maybe I found out my circuit here. All right, let's see if I start with, I don't think, nope, that didn't work. I don't think this is going to have a, nope. All right. One more time. I don't think this is going to work. Yeah, I'm stuck. All right, so due to time, I'm going to say that this only has a Hamiltonian path. If you happen to find a circuit, let me know. All right, so find the chromatic number. All right, so the chromatic number, I'm going to label a 1 with a red. Remember, anything touching this 1, anything that's adjacent cannot be a red. So let's see, this 2 will be a red. This 3 will be a red. All right, next one, let's see. Let's just say this 0 is a green. That 3 cannot be green, it's touching it. Let's see. This is a green. This 2 is a blue. This 2 is a blue. All right, that's chromatic number 3. I'm going to say that's going to work. But remember, chromatic number can be sneaky, so you might want to erase it and do it all over again and see if you can't beat that number. All right, let's try this one here. A will be a blue. Let's make G a blue. E is a blue. Just thinking here. Let's see. Let's just make D a blue. We'll make B a red. Let's see. F will be a red. And then this will be a green. This will be a green. All right, so that was 3. Let's see if I can beat that. I think I might have seen another way. All right, so I want to stay with A being blue. All right, let's see if I can beat this. All right, so I'm thinking let's make G a blue, C a blue. Okay, what I was thinking it wasn't going to work. So oh, wait a minute, you're probably screaming at the. I can make that a blue. Awesome. All right, so okay, maybe I was thinking smart early this morning. Man, look at that. That's exactly 2. Nope, that's not 3. That is 2. Correct number 2. All right. Next one in a round robin ping pong tournament. The results were shown below. All right, so remember that the loser gets the arrow. All right, so the loser gets the arrow. I'm going to try to do my fat arrows. All right, so the loser. So John, well, I don't know what just happened. Hold on. Let's try this one more time. All right, so, all right. Try one more time. Technical difficulties. I think my finger hit the wrong button. All right, so let's try this one more time. I'm still getting a little spinny thing. All right, so John beat Bill. So John is pointing to Bill because he's a loser. Dave beat Joe. He's a loser. Let's see. Bill beat Joe. Ed beat Joe. Apparently Joe's not very good. Dave beat Bill. John beat Ed. Dave beat Ed. Let's see. John beat Joe. Joe looks like he's going to be our loser here, but we're just going to keep going. Dave beat John. And then Ed beat Bill. All right. So let's total up our wins and losses here. All right. So Bill, let's go around the horn. He was 1-3. Dave was 4-0. He's obviously our winner here. John is 3-1. Ed is split 2-2, and poor Joe got beat up. He's 0-4. All right, so who came in first place? That would be Dave. Second place would be John. Third place would be Ed. Fourth place would be Bill. And then I guess I should have spelled out John since we have 2 J's here. And Joe came in 5th place. Awesome. All right, so if a tree had 10 vertices, how many edges would it have? All right, so this one here, this is something that's different. We've never really had this question, so I'm going to invite you to draw it out. 10 vertices. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Now remember, a tree, no cycles, everything's connected. So I'm just going to connect them all. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, that's 9 vertices. I'm sorry, 9 edges, sorry. How many total degrees? Now, if you remember anything from what I told you about the relationship, it's always going to be double how many edges. But if you want to do it the old-fashioned way, that vertex has a degree of 1, 2, 2. That is a degree of 2, 2, 2. That has a degree of 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 1. There we go. So there you go. Count them all up, you get 18. All right. So what we have here is a traveling salesman problem where we're going to have to put all of our information down here. All right. So if you remember how to do this, and we went over it a couple times, I went ahead and set up everything for you just to make it a little easier. So if you notice on this very first branch here that I'm about to circle, we're going from A and then we're going to B. All right, so we're going from A to B. So that means our first split after B, that will be a CD situation, which would be a DC situation. All right, so A to C, that will be B, D, D, B. That's a B to C, and that's a C to B situation. All right, let me view. I need to see a little more here. All right, so now we're going to take our numbers and plug them in here. All right, And the way always like to do is I like to take one edge at a time. So like A to B. A to B, that was 20. So I'm just going to fill out all my 20s. A to B, which is right there. A to B, which is right there. Next one would be A to C. A to C is right there, 42. Now, how you fill out the numbers is totally up to you. I'm just doing it this way. All right, let's see. Next will be A to D, which is 35. All right, A to D. Oh, there we go. There's 35. There's 35. I don't think that's it. All right, I'm just going to go ahead and do CD because it's right there. CD, anywhere I see a CD, that's going to be a 12. That's a 12. CD, that's a 12. That's a 12. All right, what am I missing? All right, this 30, which is a CB. CB is a 30, 30, 30. That's like 30. And then last, okay, that's a 34. That's a DB situation. 34, 34. You might be fast forwarding through this part. All right, so when I add, I'm going to add all my branches here. I'm going to start with A, go all the way down here, and add all of this. All right, so I'm trying to find a calculator. Oh, come on. All right, so let me count right here. I think I can do this in my head, but I'll be clear. It's early this morning. Plus 12 plus 35. All right, I believe that is 97. For this branch, ends up being 97. You do the same thing for the next one. Let's see, that's 54 plus 12 plus 42. That's 108. So 97, 108. All right, let's see, it's 72 plus 34 plus 35. Oh, this is a big one, 141. All right, after this, I should be having some repeats here. So let's see, 42 plus 12 plus 34 plus 20. Try that again. 42 plus 12 plus 34 plus 20. Enter. Okay, there's my first repeat, which is 108. That's good. All right, our next one. Oh, forgot this DB here. Let's see, DB was 34. I bet y'all are yelling at the screen. All right, so 35 plus 34 plus 30 plus 42. Okay, I'm using this yellow calculator. And I didn't do it right. All right, 35 plus 34 plus 72. I got 141. There's my other repeat. Good. And then let's see, 35 plus 12 plus 30 plus 50. Enter. Okay. 35 plus 12 plus. There it is, 97. All right. So everything's repeating. That's good. Let's answer questions. What is the total weight of the shortest circuit? Well, the shortest circuit was, if I remember correctly, 97. So this is 97. And of course, it's miles. I didn't say the directions, but what is the weight of the nearest neighbor? All right, so now we got to do nearest neighbor. So let me zoom in a little bit. All right, so our nearest neighbor, we got to figure that out. Remember, you're moving to your nearest neighbor. All right, so starting with vertex A, let's go to its nearest neighbor. That is B. From B, our nearest neighbor would be C. C, our nearest neighbor would be D. And then we got to complete the circuit back to here. All right, so I'm going to add that since I'm just sitting here. That's 50 plus 35 plus 12. Ooh, that equals 97 too. All right, so we have 97 again. If you were driving a car that had fuel consumption of 20 miles per gallon, how much would the longest circuit be? All right, so our longest circuit was 141. So I'm going to simply take 141. I'm going to divide that by 20. I'm going to get the number of gallons I need. And then I'm going to times that by 215. All right? So 141 divided by 20, enter. Times that by 2.15. I'm going to round. We're going to say it's $15.16. Dollar sign on there. All right. Is the following graph connected? Well, just looking, I don't see any floating parts. So yes, it is. Is the following graph complete? Now, complete means I cannot add anything else to it. That means all the edges that can be drawn will be drawn. But I happen to see this just because I happen to look. Well, look at that. I just connected that. That means there's more edges to be drawn, so obviously it's not complete because I could keep going. So the answer is no. Create an adjacency matrix. All right, there's an A to A situation. That's a 1. A to B is a 1. A to C is a 3. B to A is a 1. B to B, there's nothing there. And B to C, there's a 1. And lastly, C to A, that's a 3. C to B, that's a 1. And lastly, there's no that. All right, there you go. That's easy. The shortest route. All right, I got to zoom out on this one. All right, so our first one is A to B. So here's A. I got to highlight that just so I can. A, and there's B. All right, just got to get there. I think the shortest route is going to be, let's see, A to B, which is 15. All right, I don't think that's. Do I have more? Let's see, let me zoom. Okay, well, I got a lot. All right, so B is going to be 15. I'm just going to write 15 there. It helps me remember. A to C, let's see, A to C, where are you, C, which is at 55. I don't see any faster way to get there other than 55. All right, so A to C is 55. So I'm going to put a 55 on there. A to D, okay, so let's see, that's 55, 28. No, that's 20, 21. I think that's going to be it. So that D will be 41. I'm doing this early in the morning, so I might mess up. So if I do, just let me know. All right, A to E. A to E, I think the quickest way is just to go straight to 80. That's 20 miles. All right, A to F. Where's F? Oh, there it is. All right, so I can go to B to F, but that'd be a grand total of like 33. All right, so this is going to be 25 miles. All right, A to F is 25. Let's see, next one is A to G. Where's G? All right, so A to G is right there. I don't think I can beat it. That's going to be 24. All right, A to H. Let's see, where's H? There it is right there. All right, so 4112. That's like 53. 24, that's like 37. I think it's going to be 53. Again, I'm doing this really quickly. I don't want to waste too much time doing this. All right, so next is going to be A to I. Let's see. I already know that A to G is 24. I already know A to F is 25. So that would be an additional, let's see, 24, 17, that's 41. But also 25, 16, that's 41. Either way, it's going to be 41. A to J, which is over here. See, 55 plus 29. That would give me, what, 84? But 53 to 24, that would give me 77. So J would be 77. And then A to K, let's see. I think it would be I to K, which would be 66. There you go. Now, see, I recommend putting numbers on each of these cities, so to speak, each of these vertices, because you don't have to go back to A. You already know that, okay, from A to E is certain, A to G. So you just kind of build off from the numbers you wrote down. That's what I would recommend. Find the circuit nearest neighbor, all right? Starting with vertex A. All right, let's go ahead and do our nearest neighbor. Nearest neighbor, is right there. From there, our nearest neighbor, let's see, is right there. From here, all right, it's going a little paradox because technically it's going back to A, but we can't go back to A. We've got to finish our circuit. All right, so there, and then lastly, boom, there we go. All right, let's see what page am I on. Oh, last page. All right, so construct a tree of 8 vertices. 3 of the vertices will be leaves. All right, so in my class, I tell them just to select 3. All right, so 1, 2, 3. All right, those are my 3 leaves, and I'm going to connect everybody else like so, and then I'm just going to connect them at random. There we go. How many total degrees are in this? Let's see. Well, that has a degree of 1, that's a degree of 2, 2, 2, that is a degree of 3, that is a degree of 2, that is a degree of 1, that is a degree of 1. All right, so let's see. 1, 2, 3, 4, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7. Yep, that works. All right, is the following tree. All right, so this is a tree. It's connected and there's no cycles. This, oh, look at that. Nope. Why? Because of this. That's a cycle. It's a closed-in part. Oh, this is a no too. Why? Because this right here is not connected. All right, so connected, no cycles. All right, create a graph. All right, so create a graph. Let's get my straight line tool here. All right, so A to D, like so. D to A, like so, going back. E to C, like so. A to B, like so. So, and then lastly, A to A. I'm just going to go ahead and draw the loop. There we go. All right. Is this graph complete? No, because I can easily start drawing stuff. Start drawing edges. Is it connected? No, it's not connected. Now I'll highlight for folks so you can see it. Here is one graph, is a triangle. And then here's my other graph, which is EC. Is lying on top of it, but it's not connected. So the answer is no. All right, I believe that is it. Yep. So hopefully you learned something. Let me know if you have any questions. Thank you very much.